Hey guys, welcome back to our second tutorial on demystifying diode circuit. In the previous tutorial we saw a diode clipper circuit, specifically the positive clipper circuit. In this tutorial we're going to talk about the negative clipping circuit. If you watched the previous practical tutorial on the positive clipping circuit, at the end of the tutorial I asked a question on what will happen if you swap these DC voltage source. What will happen to the output waveform. Great. Now, so this is what we basically going to see in this negative clipping circuit here, because the only difference between the previous circuit and this one is the voltage source that have been now swapped around. Okay, but now first thing first, what's going on in this circuit? We've got an input waveform here, which is basically a sinusoidal AC waveform, which will have a frequency component of either 50, 60 Hertz or what have you. Okay, and that is now input into the circuit where we've got the DC voltage source, okay, and a diode, which is basically going to be controlling the clipping of these waveforms, so we can have a output waveform that looks something like this. Then you have a load resistance. Now this load resistance is very important because this output is measured across the load resistance. By the way, if you find this tutorial useful and you'd like to see more electronics tips and tutorial, make sure you give it a thumbs up and subscribe to my channel. That will be highly appreciated. Thank you so very much for the support. Now essentially what we have here is a half wave rectifier with a DC source that will basically decide the clipping point for the negative peak, for the negative waveform. So now let's go ahead and analyze circle by circle what's going to happen here. So this is our input. So we've got the first circle here, so we have a representation of two circles here. Now let's go ahead and just analyze the first circle. So what's going to happen at the first positive peak when your input goes to plus V max? Okay, now the diode is going to be reverse biased. When it's reverse biased, that means there is no current that will flow across your RL, your load resistance, which means you're not going to measure anything. You're going to have zero on the first positive circle. Now the dotted line here basically indicate that your output that was supposed to follow the input have been clipped to zero because the diode is in reverse bias. As your input voltage continue to decrease until it reach the negative peak here, okay, now in this case your diode is now going to become forward bias at a negative peak. This basically means the input here, right, to the diode becomes negative, and your diode will conduct because we've got the cathode will be now connected to a negative voltage, so it will conduct. Then at this point your negative circle here will then be passed to the output, as you can see. But now we're not seeing the whole output here, we're only seeing the portion of the negative peak. As you can see, we've got quite a huge chunk of voltage here compared to here we've got just a small portion. What is happening here? This is where these DC voltage source come into effect. Now if you remember in the previous tutorial I asked flip these DC source and observe what will happen on the output. This is what will happen, because if you flip this by providing a negative to the cathode of the diode, then it will add onto the portions of your output, right? And when you do that, it effectively adds that DC bias, right? It basically add it, overlay it on top of your positive peak voltage. This is why your Vmax is basically going to be Vmax plus the V. So that is on a positive clip. And when you do that, your output here will basically going to be your Vmax plus whatever you have here, and that's what we saw on the practical tutorial. But in this case, when you reverse the polarities of your voltage source, so in the negative peak instead of these being added to your negative peak, it's then going to subtract. So your output is going to just look a small portion here instead of being a full negative peak, because we're subtracting your negative V max here minus whatever V is. As a result, the output voltage is going to be reduced. So this is what we're calling a negative clipping. You are basically clipping the negative portion of your output, so you can effectively decide what you want to do, how you want your output here to be, depending on what you input here on your DC voltage source. So if this is fixed, you cannot change this, but you can change the output here by adding this series input DC voltage source. That's basically what you are doing here. You're modifying the output even though you don't have control of the input, simply by playing with the electronics here. Any voltage more negative than this voltage is going to be clipped and cut out. As a result, the output waveform, the positive half circle, remain unchanged, but you're not gonna see it here because this is a half wave rectifier. Only if you add another diode to make it a full wave rectifier, you should be able to see that positive half will remain unchanged, but the negative half will be clipped at V, at the input DC voltage source, basically at negative V. So the key takeaway here is that the DC voltage source can determine the clipping level, as I've already said earlier. So this circuit is basically essential for wave shaping. So if you want to shape your waveform, depending on the type of application you want voltage limiting circuit, this is how you can achieve it with very simple component. Now if you want to clip the positive portion of the circuit rather than the negative portion, all you have to do is change the direction of this diode. Okay, flip the diode. Then by flipping the direction of the DC source, you can then also decide on how much positive peak you want to basically clip and return your negative peak if you're still going to be dealing with a half wave rectifier. So in conclusion, guys, this circuit is good for signal processing. Okay, you can use it in AM, amplitude modulation radio receivers, to basically remove unwanted portions of your signal that you do not want to see, and also for voltage protection circuit, where you can limit the voltage level to protect, to basically protect sensitive electronics. It's also useful for waveform shaping. As we've said earlier, you can basically decide how you want your waveform to look like, okay, using digital signal processing to basically generate specific waveforms. The bias diode clipper circuit is very crucial in electronics, allowing us to basically have control and modify signal by adjusting the bias levels. Okay, so we can set precise clipping points for different applications. So thank you guys for watching. If you find this tutorial useful, make sure you give it a thumbs up and subscribe to CMTEQ channel. Stay tuned for the practical demonstration for the negative clipping circuit coming up.